Welcome to a new edition of the Heat Treat podcast. Today we have one of the most influential people on the heat treat industry, a personal friend of mine and a mentor, Mr. Steve Thompson, CEO of Super Systems Incorporated, or how friends call it, SSI. How's it going, Steve?
It's going good. Thank you. Those are very kind words, Carlos.
First of all, I'm super honored that I know you're a very busy guy, but always talking to you. It's super cool. You've been in the industry for quite some time. You're a second generation. I would love to have a podcast with your dad, with Bill Thompson, and today we're gonna talk about one of the most important products for the atmosphere heat treat industry, which is the oxygen probe. Actually, I got one here today. It's going to be kind of one of those product review podcasts, and it's called an oxygen probe. The one that Super Systems sells is called the Gold Probe, right? And today we're going to cover oxygen probe technology. So if you could give us an introduction, a little history and background of the oxygen probe technology, that'll be fantastic, Steve.
Okay. Well, I actually took the opportunity to have a cup of coffee with my dad this morning. I'm visiting with him, and I asked him to kind of give me his view of where he started and his understanding of the oxygen probe technology, just to kind of firm up what I believed or I have heard over the last 4 decades. And I think what's really interesting about the zirconia probe technology is it began with NASA in the 60s. NASA had tried to develop a technology to generate oxygen. And with the zirconia material that's used in not only the gold probe, but all high temperature oxygen probes, if you apply a voltage across the material, you can generate oxygen ions. And for obvious reasons, NASA wanted to create oxygen, but it is very small in concentration. It's molecular, and NASA abandoned that project, but they were transparent with industry. So as NASA is most times, and that technology was then used by the industrial market for measuring the opposite of generating, but measuring small amounts of oxygen. And it was commonly used in flue gas and boiler type applications in the late 60s and 70s, where they were using an oxidizing noble metal electrode, which is compatible with high concentrations of oxygen. And then from there, that technology advanced to the atmosphere side, but you couldn't use a noble metal. You had to use a nickel chrome electrode that wouldn't deteriorate when you use a reducing application. So with oxygen probes, if you have a high concentration of gas or no air on one side of the electrode, and you have a large amount of oxygen on the other side, and I say air and oxygen interchangeably, but I really specifically oxygen, there's 20% oxygen in air. If you have 20% oxygen on one side of the zirconia and no oxygen on the other, which would be an atmosphere reducing application, you'll generate a small DC voltage. That voltage is used to calculate carbon. So in the late 70s, there were a couple of different companies that were developing this technology, and one was Cambridge Instruments, Kent Cambridge. It was really the two companies together. They became one, and also there was a company in the U.S., AACC, which was Bob Blumenthal and Andy Melville. And
were these companies devoted to the heat treat industry or some other industry?
Well, no, they were. Well, that's a great question. So Cambridge and Kent were not. They were a medical company. They were involved in measuring oxygen and conductivity and pH, and they had an industrial division. And they had a small group, if you will, on that development of the oxygen probe for the reducing applications. I can't speak to AACC. I believe that they were focused specifically on developing that technology for that application. But you'd have to reach out to maybe like an Andy Melville. I bet he could expand upon that quite a bit. But to their credit, in the US, they developed it, and then Cambridge Kent in England developed the technology. And that's kind of where my dad, Bill Thompson, started. He was a product manager for that company. And under that product group, he had the zirconia probe for the industrial applications. He transferred to the US and led the charge in developing and marketing that product for reducing atmosphere applications. So the two companies were developing and building a better product as every product improves with time, and explaining to the industry how this new technology could make significant changes in quality in the final product of metal parts going through furnaces. And the problem is there wasn't a microprocessor at that time, so they would actually measure.
We're back in the 70s, right?
Yeah, so this would be the 70s, and they were measuring in kilocalories. And when you went into a heat treater and tried to explain this technology that would provide a voltage that was equal to a kilocalorie, what is a kilocalorie? There's only a small group of people that took that class and understand what that is. And heat treaters were just kind of really glazed over by that. But so what they did is there was a company or an individual that developed the first instrument that took that voltage and provided a lookup table to be able to control to a certain carbon at a certain temperature with a certain CO. Because keep in mind, this is an oxygen probe. It's not a carbon probe. We refer to it as a carbon probe, but it's really measuring the lack of oxygen, generating a low DC signal. And with that measurement of oxygen, if we have temperature and we know the CO, and in most cases, CO is typically 20 to 24%, depending on the endothermic or nitrogen methanol source, we can calculate with the Nernst equation carbon. But back in the 70s, they weren't doing that. They were really taking the kilocalories, had a lookup table, and then controlling to a point. I don't know if you remember the Alnor, kind of a similar analogy. You had a chart, you looked at the temperature, you looked where the fog was, you looked at your chart, and you figured out where your dew point was. Well, kind of similar, I guess. But then shortly after, the first microprocessors came out, and there was an instrument called the 550 that was the first very large boxy type instrument that was able to control with a microprocessor. And then there was a group, Don Riemenschneider and Dan McCurdy, that developed one of the first automated process controllers, and then became part of what was Marathon Monitors, actually. And they had the first programmable microprocessor-based controller. With the microprocessor, they were able to utilize an algorithm, the Nernst equation, to calculate carbon based on that pure oxygen millivolt reading, temperature, and CO. And then from there, the technology continued to grow, and many other companies embraced it and developed, control and automated solutions. So and today, the zirconia probe is everywhere in the world.
I will assume the microprocessor came in the 80s, right? When I spoke IBM computer technology was growing, and the first microprocessor controller actually came to the market.
Yeah, I can't speak to exactly when it came to the market. I did ask my dad, and he was saying in the 70s, microprocessor technology, late 70s, early 80s. And it was this instrument was the 5500, actually, I'm just checking my notes, that an individual designed that could do the algorithm. And then from there, it was early mid 80s with Marathon using microprocessor technology. But yeah, it was all around the time of the computer, the beginning of the Apple and Microsoft dynasties, right?
So I got a basic question. So during those times, you were using the oxygen probe in order to measure. Nowadays, we use to measure and recalibrate. We can get a signal and actually have the instrument talk to the PLC or to the flow meter or to the valves, so we can actually adjust the atmosphere to the carbon potential that we need. Back in those days, just was to get a reading and adjust it manually.
Well, it originally was to measure and indicate, but it was very quickly, there was control technology that was put together, and that was that product I referred to that measured kilocalories and had a lookup table that it would tell you, where to turn the gas on and where to turn the gas off. And then with some technologies like combustion and steel and petrochem, it's used to this day really to indicate, monitor, and alarm. But with atmosphere heat treating, very quickly it was used to control the process, because it is a very controllable process for carbon by adding gas or air, preferably gas, unless you're diffusing. So very quickly, the people figured out a way with a carbon index product is one of the names that was used, and then the microprocessor where you would cycle air and gas on to control. So.
And well, now that we know a little of the history of the GoPro, can you just tell us how does it works, and the most common mistakes heat treaters fall into when they're using it, and how to fix them really quickly? I mean, because since I met you, you've been into many heat treat shops, you're troubleshooting probes, promoting probes, and most of the time, heat treaters tend to believe that their probe is bad, and with some small adjustments, it wasn't bad. It was just that it was not well taken care of.
Well, yeah, I mean, like with every product, there's a certain amount of education that takes place, and as people move through organizations or retire, you have to re-educate. The zirconia probe in the beginning, the reliability wasn't there. Today, they're incredibly reliable, but there are certain things you have to do to have, readings that you can depend on. And for example, it's very important that you provide reference air to a probe. And a common problem when you walk into a heat treat, if you look, a lot of times there may not be air flowing. We talked about earlier, we have to have a 20% oxygen on the inside of the cell. It goes down into that tube and it comes back out. It doesn't go through it. The ions, the partial pressure, the ions travel and create a voltage, but the actual flow of air goes into the tube and out to provide that 20% reference. So if you don't have a good reference air flowing and the air becomes stagnant, you may not have 20%, you may have 18% in that tube after a few days. So now that probe is going to read an error, which means your carbon's going to read an error. So it's important that you have reference air. The other problem that we run into is, everybody carburizes frankly, quite frequently in the zone of saturation. And if you do that, you get carbon in your furnace and you have to burn it out, but you also get carbon in your probe. So you have to burn out your probe, and burning out a probe properly. And here's an area where, we've spent a lot of years looking at the best burnout, not to degrade the probe by burnout, but to keep it clean and to optimize the life. So, the conclusion that I've come to over the years is you want to be able to effectively get the air across the tip of the probe, but not overheat the probe during burnout, but enough time to consume any carbon. So if you're doing it regularly, and I would never do it more than every 8 hours if I could avoid it, for 90 seconds with at least 10 to 15 SCFH, you're going to effectively burn out the probe. That, along with good reference air and then a calibrated instrument, you're going to have a reliable signal. And everybody asks the question, how long does a probe last? What should I expect for life? Well, that's not an easy answer, because what temperature is the furnace? Are you effectively burning it out? What kind of stop-off materials do you have? What kind of washing or chemicals is the probe going to be exposed to? So, it really depends. A probe, to think about a probe in a continuous furnace, let's say at 1650 degrees Fahrenheit, continuously at that temperature, it may last 7-10 years if it's cleaned with a proper burnout.
Because of the thermal shock, right?
Right, because what happens when in a batch furnace, for example, when you put a probe in, every time the furnace quenches, it cools down with the load and heats back up. Well, every time you do that, the probe is growing and shrinking. That's why it's a spring-loaded electrode. The zirconia is not growing, but the sheath and the internal electrode are growing. And so the springs are there to maintain good electrical contact. But you can imagine that's a lot more wear and tear on that product than it is in a continuous furnace. So it really depends on the application. When someone says, well, how long will it last? And it depends on how they take care of it. But, we warranty for a year, but we see probes lasting much, much longer, which is another problem, because now they may not be reading as accurately as they should be if they've been in there 3 years. So we recommend at a year and a half, you pull your probe and get it rebuilt. But you can also establish your own timelines. It's also important to note, Carlos, that when you're using an oxygen probe, it's a measurement. It's an inferred measurement of carbon. It's calculated. You have to have a verification process. And especially if you adhere to CQI-9 and your internal quality system, you should be doing a shim, which is a shim is the only true measurement of carbon.
Well, they call it like a second way of measuring the atmosphere, right? A shim might be, you can do a coil, maybe do a gas analysis.
Yeah. Yeah, and we at SSI are in the business of making every possible solution to measure carbon. I mean, that's what we've done to grow the business.
Right.
But I'm here to tell you that the only true measurement of carbon is a shim, and you should never get away from that. There's lots of other verifications that are important: 3-gas, dew point, coil. But again, those are all inferred measurements. But carbon absorbed into steel and looked at under a microscope is really where you want a verification. So. But the beautiful part about an oxygen probe is in situ. It changes immediately as the process changes, and it requires very, very little maintenance other than the burnout, the reference air. And the other one is insertion. You don't want to, if you put it in too far, and let's say you're at 1700 or 920 degrees Celsius or thereabouts, you'll see that the probe may sag, which then creates other problems. But these are all things that are on our website, for example, under our technical papers, resources, and documentation, technical papers, where we've kind of covered all the things to look for in troubleshooting probes over the years. And we're still learning. When you think you've seen it all, there's usually one right around the corner. So a new one, that is.
And there are different sizes of probes, different thickness, different thermocouples on probes, and those depends regarding the application, the furnace, the country. Because I know that SSI ships a lot of probes worldwide.
Yeah, that's right.
What do you see regarding the standards? Are USA probes like one type, European probes, Asian probes? Different types of furnace, different type of gases, applications. What can you comment about it?
Well, it's a great question, because there are different varieties of probes. So you have different thermocouple types, different lengths, different diameter sheaths. The standard, probably 80% of the applications it's a 600 millimeter probe or 750 millimeter length probe.
Like the one I have here?
Yeah, that's a 600 millimeter probe, and that's going to fit in most furnaces. But there are today furnaces with much thicker brickwork, so you may need to have a 750 millimeter. Mm-hmm. Now, I will say there is one interesting thing in specific to the gold probe, is that we have what's called a coated sheath, an aluminized sheath, where in some applications, high temperature, high carbon, you get a lot of green rot where the chrome is leaching out of the alloy, or you have a carbon ring that builds up when you have free methane back in the 900 to 1300 Fahrenheit range. And using that, creating a barrier from the nickel in the alloy, you stop that carbon from precipitating out, and you get a longer life for high carbon, high temperature. You have, when you get to very long probes, and you may need those in a pit furnace, you're going through a baffling, or there's a significant space, we have what we call the XL. It's got a thicker diameter sheath and a different spring configuration. And they get expensive. And then there's ceramic probes. But one thing I do want to touch on is the thermocouple. So the people buy K thermocouples because they're very inexpensive in the probe, but they are very small in diameter, and they are not rated. I'm not sure exactly the spec, but if you're like 1600 and higher, it has a short life because it's a very small diameter, 8 thousandths wire. Whereas an S, which is much, much more expensive, but is platinum rhodium, it will not be the point of failure in that probe. It will outlast the electrode in zirconia because it is a very durable and very precise measurement. And we all know that as we buy thermocouples or furnaces, an S is very expensive, but the measurement of oxygen and temperature at the tip of the probe is very important. And if the thermocouple is not in the probe, you can use your control TC, but you may have a difference in temperature, which adds a little bit of error. But that can be overcome by the CO factor setting using a shim. And the CO factor is how you adjust the carbon calculation to match the actual carbon in the furnace or in the part using the COF. So if you elect not to use a thermocouple in the probe, that's okay. You can use the control TC. But for the optimum accuracy, a platinum rhodium S or R thermocouple in the probe provides the best reading. And a K thermocouple, it will work, but it's really a lower cost, less reliable solution long term. Now, if you're using a control TC, it's okay that it's a K because it's a very large diameter thermocouple. So, I can talk a lot about this subject. That's probably enough for everybody, but those are things to consider.
It's a very technical, conversation. I know you're very passionate about it. And I got a couple of questions regarding it because, in the podcast we have had this conversation that, there's a market for atmosphere, well, definitely vacuum is growing, right? Hasn't there been some tries to get like a carbon measurement on vacuum furnaces? In a way, it might be a probe or an analyzer. What do you believe are the trends? Is
Well,
atmosphere is going to stay
we're
strong? Is vacuum is going to grow, or they're going to find their way and have kind of a nice balance? What are your thoughts on that?
well, we started out as an atmosphere controls sensor company, and today we are more vacuum than we are atmosphere because the market has, I believe, shifted that way. And of course, vacuum carburizing. So we are always looking for opportunities to develop technology that can be used in whatever the market needs, whatever our customers are asking for. So, using our hydrogen cell, for example, on a vacuum carburizer is something that we're developing and have installed, and that's not new to the industry. Other people do that, but we have a sensor that can be used in that application. Oxygen probes don't work. It's a partial pressure measurement, so it's not going to work under a vacuum type application. So there's the measurement of hydrogen, CO2, and those are sensors that we manufacture, and we're involved with those industries with. I think that we're all waiting to see how the electric car impacts our industry. When you look at the data, and you look at, this is all prior to COVID, of course, so things have changed. But in 2028, I believe there was an evening out of electric versus combustion cars. And what's that going to do to heat treating as a whole, and atmosphere heat treating versus vacuum carburizing? I don't know. But I do know that there's a tremendous amount of business out there. And I do know that, and this is what I really like to hang my hat on, the oxygen probe market is very, very mature. And I can tell you that it's still growing. Every year for the last 28 years for SSI, every year we've grown with a few dips here and there. And with more global reach, more educated customers, more people trying to drive to a higher quality product, that market continues to grow. Will it slow down at some point with the change in industries? Maybe it will, but I bet we'll find other applications to use that technology. And along with hydrogen sensors and CO and CO2 and dew point, which are all things we do. So it's going to be interesting.
And you and I have talked about it in the past, and right now we're recording this the 17th of June, and the market has crashed. But
Oh yeah.
but I always tell people, that there's the oxygen probe index on heat treat.
That's right. Yeah.
It's when you're selling a bunch of probes, I will assume by logic that the heat treatment industry is actually booming, right? Because they're using and burning out their probes. When you're not selling as much probes as you used to, it means that it's the selling. Do you have a comment on that?
I do.
Is this a fair trend? The gold probe index.
The gold probe index, you're 100% right. So I can look at the monthly sales of probes, and I can look at trends. You may have a bad month and then a good month, and a bad month and a good month. Well, it's not really. It's just telling you we are where we are. But when people start shutting off furnaces, or if there's a crisis like in 2008 and 9, people were not just shutting off furnaces, they were taking probes out of furnaces and using them and not buying probes. We can see that immediately on our income statement as I look at that product, and I can see, and I do a month-to-month, year-to-year comparison, and I can look at the trends, and it is really an indicator of what's going on economically with heat treaters. And I can tell you that for the last couple of years, it's been very strong, and I have not yet seen that turn down. But if you look at the financial markets right now, it's depressing, right? And now you're hearing all the other things about the housing pulling back. So I think we may see around the corner the gold probe index pull back. I don't know. I hope not. But right now it's a challenge keeping them on the shelf. But especially with all the other supply issues, we're ahead of it on our end. But there's a lot of challenges right now. But
right.
See.
Right. Well, something I would like to touch on very quickly, because SSI and basically yourself have devoted a lot of time to the data and trends and charts. And now with all this booming of the big data and metadata and you name it, We talked about the probe, taking a signal to a microprocessor, which is a controller right now, and giving a signal in, giving a signal out, and then you have a SCADA systems which you actually connect those controllers to, and you get a bunch of data. What do you think on today's world that everything is about big data and everything on the heat treat industry? Are we just reading the data so we can control the atmosphere, or is it going to come a time in which we can say we're going to adjust the recipe or the furnace by the data we're getting, or how the furnace is behaving, so we can have better parts with better process? I'm not saying AI, but a way just to digest the data we're getting, because we're getting a bunch of data from many probes all over the world. Is there a way we could actually use that data back to improve the process of heat treatment itself?
Well, I think that, as a technology company, that's what we're looking towards with all of our products, with especially the SCADA packages and process, automating processes in plant, using the Internet of Things and having that data create, information and opportunities. And, we're using the data all the time. We always have with super data, and taking it to the next level and looking around us at other industries and how they're doing it and how do we apply it to heat treat. I mean, that's happening, carbon footprint, process gases and electricity cost per load, and how that impacts other loads and other processes. Those are the things that we're looking at. How do we calculate a carbon footprint? Because there seems to be a strong trend to knowing what that is. We have the tools to measure it all. Now let's utilize that information to feed that information up, and then that ultimately feeds more information down, right? Those are the things we're looking at. But that's no small task, I can tell you.
It is not, but I believe, and this is my personal opinion, that other industries like CNC, they're way ahead of heat treatment on IoT, right?
Yeah.
But if there's somebody that can do it, I will assume it's SSI, because actually that's why you do. You're all about data. We talked today about the gold probe, but you're collecting data. We just need to figure out a way how to read it and actually give something back to the process. And I don't know how it's going to work, but I believe that's the future, right?
No, it is the future. And, we want to be less dependent on operators, but then when we have operators, we want them to be well educated. So, how do we manage those challenges by automating processes, but having educated people able to technically handle the processes that we're creating, and troubleshoot them. Those are the challenges, right? There's less people on the floor that can look at a flame and tell you what the dew point is. So we better be able to measure it and check it and communicate it and use that information proactively than waiting a week to find out we're making a bad endothermic gas feed in the furnaces. So those are the challenges in our industry. And then we have a younger generation, and we need to rethink how we do things,
Right.
Everything is on the phone. How do we step into that sandbox? We're developing our applications so they're all web-based. You don't need a piece of software, and you can just access an IP address and look at all the things you need to know about something, whether it's a flow meter, whether it's a gas analyzer, whether it's a carburizing process. And how do we enable a younger generation to embrace that technology? We have to think like they do and stay sharp. And sometimes it's tough. You think, well, really, we're going to do this? Well, yeah, we better, because this is where it's going. So.
I think you're 100% right, and we have to make a better job at marketing our industry, because it's not as sexy as other industries, but we need to attract more of the younger generation, because there's a lot of talent that is retiring year by year, and personally, I don't believe we're filling that gap. So we need to have very strong products, very strong supplier base, in order to service the heat treat industry. Steve, it's been great talking to you about oxygen probe technology. Did we cover everything we should, or do you have something to add about gold probe technology?
Well, what I would like to add actually is I'd just like to give a shout out and credit to a former partner of my dad and a guy that I worked for. His name was Tom Lotes, and he he was key in the development of the products at Marathon, the oxygen probe technology, and also the gold probe. He had a patent with the probe, and just an amazing individual that influenced my life, and along with many other people along the way. But Tom's no longer with us, but he is a big part of why we're successful, along with Ted Berry, Bill Thompson, of course, and then many more after those three individuals that started it all.
The founding fathers of the gold probe, huh?
That's right.
Right.
Yes. Yeah,
Okay.
that's right. Yeah.
Okay, Steve, thank you so much for giving us this great podcast, great information. Coming from you means a lot, because you're very involved in the company, in the markets. You travel the world promoting the probe. You have been a witness of the evolution of it. I believe since the early microprocessors to up-to-date touch screens, fancy Bluetooth controllers now, and let's see what the future goes ahead for the heat treat industry. Now, just before we end up, I mean, you've been in heat treat on a leadership position for quite a while. You're a well-known person in the market. You have companies worldwide that are devoted to heat treat. What can you share, or how would you, what would you advise to this newer generation of heat treaters, or to the guys that are trying to make a career, to make a name for themselves on this industry that you have learned through your entire career?
Well, I guess the thing that I would share is what my dad shared with me is that, surround yourself with people you trust and people that are smarter than you, and be humble, and don't be afraid to say you screwed up. And I always tell people it's okay to make mistakes, just try not to make them a second time. But surround yourself with people that can help make you successful. And I feel like I've done that. I feel like that I've got a lot of really smart people that have created the opportunities that I've had. And then just be open-minded. Let everybody's opinion absorb in. And we all tend to want to say, oh no, or that react immediately. Just take a step back, think about what someone else has to say, and chances are you're probably going to come around to where they are. And then I guess the number one thing is take people's advice, especially people that work for you or you work for. Just let people help you be successful.
Thank you so much for your wisdom, and thanks for sharing that, Steve. Well, this has been a great podcast from Steve Thompson, CEO of Super System Incorporated, SSI, one of the most influential people in the industry. Thank you so much, Steve. It's been a blast.
Thanks, Carlos.
We'd like to remind the audience that we're uploading, not weekly now, but monthly podcasts. We're YouTube, LinkedIn, and Spotify. And thanks for hitting like.
It was awesome.
Next spot.